This is Richard with the Orchestration Scripts Winter 2019 Research Talk. In order to have a productive conversation about orchestration, we need to set our definitions. First, we have orchestration, which is how a teacher manages in real time multi-layered activities in a multi-constrained context, taken from Dillenberg. You can imagine a teacher at the front of a classroom managing his or her students such that the students learn as effectively as possible. If they detect a student struggling, they'll intervene and help the student. Second, an orchestration strategy is a teacher's plan of action given certain conditions that occur during a student's work process. This is the teacher's policy all the way from when they detect a student struggling to how they'll help that student. Third, an orchestration trigger are the conditions a teacher looks for to enact an orchestration strategy or orchestration action. These are the signals of struggle that a teacher will look for to determine whether or not a student is struggling. And finally, we have an orchestration action, which is a thing done by a teacher to manage a student's learning. This is how the teacher will help the student learn better, whether that's connecting the student to a learning resource or referring the student to a mentor. Of also important note is an orchestration failure, and that's when orchestration doesn't occur. So when a student needs help, but the teacher doesn't recognize it or isn't aware of it and doesn't end up helping the student. Stepping back a bit, we know that orchestration occurs in DTR. There's a hierarchy of mentors and mentees in which mentors attempt to orchestrate for their mentees as effectively as possible. In an ideal world, mentors would spend all of their time mentoring for their mentees such that the mentees learn as much as possible. This is assuming we don't want the mentors doing research and such. However, in reality, the mentors do research and they have their own things that they have to take care of. And because of that, their time and energy is inherently constrained. Furthermore, if a mentor takes on multiple mentees, they have to split their time among all of the mentees, meaning the mentees don't get as much orchestration attention as they necessarily need, and ineffective orchestration may occur. Current approaches to solve this issue are to use graduate students as proxy mentors, which doesn't work because it faces the exact same issues you would have if you had a normal mentor, in that graduate students are also busy, they have to do research, and if a graduate student were to take on multiple mentees, this graduate student would also have to split their time among these mentees. Second is to have guidebooks and learning modules, and although these resources are great, they don't work all the time because students may not be aware of these resources, it may be hard to find these resources, and students may not know what they're struggling with or even be aware that they're struggling at all. Finally, we can have a mentor keep track of it all. That is, one mentor keeps track of every single student's research progress, every single student's needs, and will attempt to detect whether or not whether a student is struggling. And this simply isn't scalable and would probably lead to inefficient orchestration. So here's my conceptual approach into how we can solve the issue of constrained mentor time and energy. And that's a computational mentor support tool with automated orchestration strategies. Essentially, we have the orchestration strategies that currently occur. I want to take out some of those, the ones that we can take out, and refactor them and digitize them such that they automatically run in the background. Why this approach is hard? There's a few questions we have to ask. First is, how do we enable mentors to create automated orchestration scripts with high precision and high recall? Precision and recall being the statistical sense, in that high precision, how do we make sure the orchestration triggers are accurate and we orchestrate when and only when necessary? And for recall, on precision, this is especially hard because a lot of orchestration that occurs is instinctual, in which a mentor just knows to orchestrate for their students. For recall, I mean, how do we make sure the orchestration triggers capture as many of the situations in which orchestration is necessary as possible? In a nutshell, we want to capture as many orchestration situations as possible and make sure that the situations that we do capture are actually situations that need orchestration. Second, how do we allow mentors to explore other methods of orchestration? That is, how do we allow mentors to evaluate their current orchestration strategies, and how do we enable mentors to experiment and play with other methods of helping their mentees learn? Moreover, how do we balance resources, that is mentor time, within among other things, within the classroom ecosystem? A lot of the times an orchestration action will be to refer the mentee to an expert. However, this expert is also most likely constrained in their time, so how do we make sure we're not overburdening resources in the ecosystem? Contributions I made in this quarter are 2 rounds of need finding, one for orchestration failures that occur within DTR and one for mentor orchestration strategies. The second contribution is prototyping, in that I designed a prototype for mentors to write orchestration scripts. On to the first round of need finding, the orchestration failures. In a DTR-wide survey conducted during status update, you can see exactly the exact worksheet I passed out. Don't read it. In a nutshell, what I did was I asked students, think of a time when you needed help but didn't know it, and think of a time where you didn't know how to get help. Through these questions, we collected 20 or so orchestration failures that have occurred within DTR. And moreover, given the core outcome that users want to do work, be productive, and learn, which we took both as a given but was confirmed through the survey, we found that a core obstacle to this outcome was orchestration failure. Orchestration wasn't occurring when it should have, and because of that, students were having a hard time doing work, being productive, and learning. There was a particular orchestration saga, I guess, that occurred in which one student was working on their core findings and experienced a multitude of orchestration failures which impeded their work process. We dove deep into this specific story, did multiple interviews with the student, and came up with a timeline of all the orchestration events that occurred. Moreover, we did need finding, this is the second round, of mentor orchestration. We surveyed 3 mentors about their orchestration strategies and with special interest in strategies within our constraints. So a quick aside, the strategies within our constraints are document-based orchestration strategies. Since in order to digitize orchestration, we need to have a digital trigger. And digital triggers naturally occur in student artifacts, that is, their documents such as sprint logs, design logs, and their canvases. So because of our technological constraints, we want to constrain our orchestration strategies to primarily deal with, we want to construct R, meaning this project's orchestration scripts and strategies, to primarily deal with digital artifacts. We ask mentors how they direct students when they need help and how they detect when their students do need help. And we ask mentors for the student artifacts they look for in order to detect that a student may or may not be struggling. Our results indicated that many mentors look at sprint logs and some look at canvases. One particular mentor looked at the sprint logs for oversprinting and to make sure that the stories are comprehensive. On to the design arguments. We have our problem statement that there isn't enough orchestration happening, and the ideal outcome in which students are learning and doing productive work. The core obstacle to this is that mentor time and energy is constrained, so they may not be orchestrating as effectively as possible. So we get past these by these core characteristics of our system, in which mentors choose student documents they'd like to monitor, mentors apply orchestration triggers to these documents of interest, and then mentors attach orchestration actions to these triggers. So why does this work? Well, these document-based orchestration strategies have an inherent search cost associated with them, in that the mentors, and many of them complained about this, have to find the documents within the Google Drive, pull up the document, and then read through the document looking for the actual orchestration trigger. Because we're naturally factoring out these orchestration strategies, we're essentially zeroing out the cost of this orchestration script and allowing it to run, factoring out the orchestration. However, this is all under the assumption that we can build a system that writes good orchestration scripts. More on that on the next slide, because there are many nuances in how scripts are written, and that feeds into our interface obstacles. So mentors could have difficulty expressing their orchestration strategies using our interface. The features of our interface could have misalignments with the language that the mentor uses, and that's something we have to deal with. Second, mentors may not know which of our features are useful for their orchestration strategies. That is, the mentors are able to express parts of their orchestration strategy, but they're unsure of how to use our tool to get an accurate representation. Their language doesn't match up with our language. Onto our interface model. We borrowed a lot of the research done by a finder, in that we agree that there are issues with both top-down and bottom-up construction processes, and we think that an opportunistic approach, which can pursue both top-down and bottom-up approaches simultaneously, would be both a smart approach and a very usable interface. So our desired outcomes is that users should easily find the blocks they're looking for, that is documents and subsections of documents, etc., and that users should easily connect the blocks to express their orchestration strategy. We do this by allowing users to specify documents to track along with the subportions of those documents and allow those documents and subportions to be manipulated like variables in a programming language. Second, we enable or create blocks, and we create blocks for those. We also create blocks for the general conditions that mentors may wish to monitor, along with sensible actions that mentors may wish to enact, and allow for mentors to compose all of these blocks together using logical operators such as if, and, or, and then. Onto the prototype. This is a rough sketch of what I initially wanted the prototype to look like. So here you can see the if statement as well as the then statement underneath that, connected to the sprint log. So this is the block representing the document of interest for the mentor, along with gets a new task added. So this would be a trigger. Then you see the logical connective and along with the logical connective or above it. Below that, this second row, you see a then block. So this would be the action corresponding to the orchestration trigger. The top row being an orchestration trigger and the second row being an orchestration action. Then message the mentor with, so this is the action associated, the sprint logs, so the part of the document that the mentor wishes to get, and the new task. So that is an orchestration script saying, if the sprint log gets a new task, then message the mentor with the sprint log's new task. Moving on to, this was a rough sketch, moving on to the actual paper prototype I ended up making. Keeping in mind our desired outcome that users should easily find the blocks they're looking for, that meaning documents, subsections of documents, conditions. Users should easily connect the blocks to express their orchestration strategy. Here's an example of a user writing an orchestration script for a new task on the sprint log. So you can see on the outside, there's the logical condition. When it is Sunday, if the sprint log task 2, specifying the specific task on the sprint log, updates its points, then message me on Slack with and the rest is cut out blank. So we implemented certain parts of our interface in that we created the blocks to represent the documents and subsections of documents that mentors may be interested in to promote, so that mentors would have an easy time finding these documents or subsections of documents of interest. Furthermore, we encoded the logical connectives for if and then to indicate orchestration triggers and orchestration actions. We also attempted to encode the orchestration action, that being message me on Slack with and the rest we had not gone to actually enacting that. So onto the evaluation methods for this study. There wasn't a formal study that was conducted, but we ran the prototype by a mentor to learn of the flaws in the current design with regards to usability. We wanted feedback on the interface, and in this study, mentors were asked to write an orchestration script that was prepared to test overall interface usability. It was a simple one just to see if the blocks we had could be used. I'd gotten later feedback indicating that this wasn't a very good test, and that'll be incorporated further on. Secondly, we asked the mentor to write a custom orchestration script that they'd be interested in writing. So an orchestration strategy that they had, we wanted them to encode an orchestration strategy that they had. Results and findings. The interface does not cover all subportions of documents. That is, the mentor in this case wanted to look at a specific story on the sprint log. In our interface, it wasn't entirely clear that this was possible, so that's something we need to go back and fix, potentially in some way to make it such that it's very clear to mentors how to find blocks and arrange blocks such that they can specify subsections of documents. Moreover, the mentors found that the interface was difficult to use with regards to logical operators, so the connectives for and or didn't make sense. Moreover, the interface needed more features for abstraction. This was a suggestion by the mentor. The mentor wanted to be able to create intermediate representations of their ideas. So for example, if they have a complicated trigger that involved a lot of ands and ors, they wanted to be able to abstract that idea into a separate larger block, something like abstracting a function in a programming language. On to the next steps. What we learned is that orchestration is important. It's very critical to the functioning of DTR. Orchestration failures exist, and they're very costly to the classroom ecosystem. Work doesn't get done, students become discouraged, students don't learn as much or as well. We also learned that orchestration can potentially be automated. It seems like it, given that many mentors utilize documents as their orchestration triggers for their mentees, and that many orchestration actions can also be digitized, or at least some of them. And for the ones that we can't digitize, we can we can give the default action of message the mentor, giving them an indication that, oh, orchestration may need to occur now. There are limitations. Primarily, there are the technological constraints in that we can't detect everything going on in a student during their work process, for example, emotions. Moreover, some mentor scripts are based off of gut instincts. Certain mentors just know to orchestrate at certain times, and there's not a specific trigger that they can point to. And those are things that we probably won't be able to orchestrate just because it's more of an experience-based orchestration strategy as opposed to a formally stated trigger and action. We also learned that our interface needs to be reworked to provide primitive coverage, more easy forgeability, so make it easier for mentors to find the blocks that they need, more sensible connection, so make it easier for mentors to identify how and when blocks can be connected, and better expressibility, make it easier for mentors to express their ideas in our block language. For the impact of our learnings, we think that future designs need to be scoped down and that more work needs to be put into the interface, and we anticipate that this will be a bottleneck in the future, in that the interface, since the interface is the primary way that the mentor will be scripting, we need to make sure that this is done extremely well such that the mentors are able to, one, write orchestration scripts naturally, but two, also evaluate the orchestration scripts that they've written and catch potential bugs before they occur. So what next? Well, the interface is definitely needs more iteration, given that it will be the thing that mentors will interact with. It may need additional features to encode different orchestration scripts, given that our survey size was fairly small. Moreover, we can also identify more orchestration scripts, find more things to encode, and even small things like update your design log after lips. These are orchestration strategies which may not be as complex or interesting, but still could be useful and will be useful if they're encoded. Moreover, we could do more orchestration signal searching. So that implies surveying more mentors and asking them what they look for and to indicate student struggle, because these are more things that our interface will need to encode, and having them is a good gut test as to whether or not our interface is designed well. Key takeaways. Well, we know that orchestration happens, orchestration is impactful, orchestration can be automated, or at least there's a good chance parts of it can, and that it's important to have an interface for mentors. An interface for mentors will be critically important as to whether good orchestration scripts are written or not. Good in the sense that mentors should naturally write these orchestration scripts, be able to quickly evaluate the effectiveness of these orchestration scripts, and be able to play with these orchestration scripts and test out different orchestration triggers as well as orchestration actions. Key implications: we have a development of an interface for orchestration, and we've enabled that given the signals that we've gathered and given the orchestration failures we've discovered. We've also uncovered a need for automated orchestration. Furthermore, we've enabled research into automated orchestration, using the existing tools to enact orchestration, so the interface, and expanding existing tools to allow for automating a more abstract orchestration. So taking the interface and making it able to capture more things. All right, that was 20 slides. Thank you so much for listening, and yeah, bye.